Good morning and welcome to AP Stats. First of all, I'm sorry for those of you who are in class today that I actually am not able to be in school today. Everything's fine, but I can't be in school today. So we're going to go over how to do the open-ended portion of the practice test, the FRQ. I will make it as clear as I possibly can, and we'll go from there. If anyone would like a meet, let me know, email me, and if I'm available today, I will definitely join you. Otherwise, I will answer your question through email. Number 11, give you a scenario about a fire station and whether they handle calls for medical assistance or other such calls. And you're told right off the bat that the probability of a medical assistance call is 81%, 0.81. And we're assuming independence, which means if there's an emergency, not 12 people are calling in for the same thing. When there's an accident on the highway, 911 gets a whole bunch of phone calls. So we're going to just assume independence so that the calls can be for different events. Okay, first question is actually not something to write down. Well, for me anyway. Describe what the law of large numbers says in the context of this probability. Here's what I'm looking for. Over an infinite series, over the duration of time, the probability of a phone call coming in to this precinct will be 81% medical calls. Or you could say over the infinite series of events, 81% of calls will be for medical emergencies. 81% of the calls, whatever you want to say. It's over an infinite series of calls. In the long run, in the big picture, not immediately. All right, if I get 100 calls, it's not a guarantee that 81 are going to be for medical emergencies because 100 calls isn't an infinite series. B, what's the probability that none of the next 4 are for medical assistance? Well, if there's an 81% chance of a call being for medical assistance, then the complement is 19%. So there's a 19% chance that the next call is not for medical assistance. If there's 4 calls coming in and we're looking for the probability that none of them are for medical assistance, we have to multiply the probabilities together. Assuming independence means one doesn't impact the other. There's a 19% chance each time. So if I'm looking at 4 calls in a row and I have to multiply 19% by itself 4 times, it's 0.19 to the 4th power, which is 0.0013 or 0.13%. Super low. It's really unlikely that none of the next 4 calls are for a medical emergency. Much more likely that at least one will be for a medical emergency. But there's 0.13% chance. There's your answer. Part C. You want to estimate the probability that exactly 3 of the next 4 calls are for medical assistance. Describe the design of a simulation to estimate the probability. Explain clearly how you'll use the partial randomness table to do so. First, and again, there's more than one correct answer, but here's what I would do. Since there's an 81% chance of a medical emergency, I'm going to assign the numbers 00 to 80 to indicate a medical emergency. You could have done 01 to 81 if you want. It's not a problem. So long as you also say that the remaining 2-digit numbers are for non-medical emergencies. So I would assign 81 to 99 as not a medical emergency. If you had done 01 to 81, then 82 to 00 would be not a medical emergency. You have to explain what your values mean. Then you'll say, I'm going to start at a random point of the RDT, and I'm going to look in 2-digit chunks. If that double-digit number falls within my range for medical emergency, it's a success. If not, it's a failure. That's pretty much the startup. Now, it's 3 of the next 4, so I'm going to have to look at 4 double-digit numbers at a time in a row. Don't jump around on the RDT. Makes it more complicated. So I'm going to then check 4 numbers in a row. If exactly 3 of them fall within my range, that trial of 4 represents a success in finding exactly 3 of the 4 calls to be for medical emergencies. If not, it's a failure. Okay, so carry out 5 trials and mark above each line so that someone can clearly follow your method. Now, there's no one told you had to start at the very first number. You didn't have to start at line 177, number 7. I did. It's kind of like, your first instinct, but you don't have to. Here's what I would find. In my first 5 trial, well, carry out 5 trials. So in my first trial of 4 double-digit numbers, I found 70, 34, 87, 28. 3 of those do fall in my range for a medical emergency. So that first trial is 3 of 4. It is a success. The next one is 71, 63, 41, 95. So 95 is too high, so there's 3 of 4 that are successful. That's also a success because I'm looking for 3 of 4. The next trial, 73, 63, 29, 68. All 4 were medical emergencies, so it's not a success because I'm looking for exactly 3 of 4. The next one I had 54, 30, 90, and 18. That's exactly 3 of 4 success. My last one was 76, 33, 17, 14. All 4 were medical emergencies, so it's not a success. Again, I'm looking for 3 of 4. So in summary of my simulation, I found a 60% chance of the next 4 calls yielding exactly 3 emergencies. Okay, cool. Moving on. The then. I think probably no one had a problem making the then. You might have had a problem answering 1 or 2 of the questions, though. So, we were told that we're drawing our 2 circles inside our rectangle. I'll put a D here and a C there for dog and cat. You were told that the probability of owning a dog was 0.38, owning a cat was 0.23, and owning both of them is 0.12. So the first question was make the then. So we start with the intersection. The D intersects C is 0.12. It goes right there at the intersection. 38% for dogs, but it has to include that 0.12. So the remainder is 0.26. 23% had cats, but it's got to include that 0.12. So the remainder is 0.11. Now what that means is we have this group here that adds up to 49%. So there's 51% that's just not into dogs and cats in this community. So there's 51% that are outside the intersection. That's your Venn diagram. Okay, so 12b sub I says find the probability a person owns a dog or a cat. Or, of course, is union. So it's the dog plus the cat minus the dog intersect the cat. That's the union rule. We have all that information. So it's 0.38 plus 0.23 minus 0.12. And we get 0.49. There you go. I kind of already answered that before when I said how we found who doesn't have a pet. So that's part I, sub I. The second one, double I, we want to find the probability of a person owning a dog or not owning a cat. Now, there's 2 ways to look at this. There's the easy way and there's the formulaic way. Owning a dog, we know is 38%. Owning a dog or not having a cat is having the dog and just not these guys. So the rest of the 51%. Okay, these 12% still count because it's owning a dog or doesn't have a cat. So if I go to a house and they have a dog and 5 cats, it still counts they have a dog. All right, and that's 0.89. The formulaic way is having a dog, which is D, plus not having a cat, which is the complement of C, minus the intersection of having a dog and not having a cat. That's the formulaic way to do this, all right? Because it's an or problem. It's still a union problem. Having a dog or not having a cat, subtracting the intersection of the two. So if you want to do that, it's fine. Dogs are 0.38. Not having a cat, well, 23% have cats. So what percent don't have cats? 0.77. Minus the intersection of dogs without cats. Well, here are the dogs, but the dogs without cats are right there in the 0.26. Those guys are dogs without cats. And what do you get when you take those three numbers together? Not surprisingly, 0.89. Regardless, it's 0.89. That was a harder problem to maybe visualize or process. But if you use the formula, it is straightforward. Otherwise, the shortcut was a little faster. Part 3I, was already been answered because it says the probability that a randomly selected family doesn't own a dog and doesn't own a cat, probability of no dog and no cat, it's the people down here in the 0.51 because they don't have either one of them. Okay. Finally, 13, we have, by the way, these were written, these problems, years ago. It's just crazy that one of our problems had to do with a flu epidemic. Right now, your school is in the midst of a flu epidemic. Well, it kind of is. So let's answer this question and not worry too much about the variety of flu that we are currently experiencing. We are told there's a probability of a student going to the nurse who has a flu, 0.35, has the flu. So there's flu, and that's a 0.35. So obviously you could also go with no flu at 0.65. So far, so good. Now, obviously, flu has a high incidence of fever. So for those with flu, there is a 90% chance of a high fever, but maybe the person's got a good amount of Tylenol in their system. 10% of them have no high fever. There are other illnesses, of course, so you can certainly go to the nurse without the flu, but you do have a high fever. And apparently, there's a 12% chance of that occurring. So 12% of the people that don't have the flu will still have a high fever. But of course, that means that the other people have no fever, 88%. Suppose a student walks into the nurse's office with a high fever. What's the probability that the person has a flu? So again, the person walks into the office with a high fever. So we're only going to look at the feverish people. We want to find the probability the person has the flu. So it's probability of flu given the person has a high fever. What we're going to do, what we always do, is find the probabilities of these values occurring. So flu with fever, flu without, no flu with fever, no flu without, by multiplying those probabilities together. So flu with fever is 0.315. Flu with no fever, 0.035. No flu with fever, 0.078. And no flu, no fever, 0.572. Because we're talking only about the people that have a fever, it's only the 0.315 and the 0.078 that matter. If you remember, the probability of a condition is equal to the intersection, so flu intersect fever, divided by the condition, fever. So flu intersect fever is 0.315. But the fever happens 0.315 as well as 0.078. Maybe I'm over explaining this, maybe I'm not, but the answer is 0.8015. We also do like words in these kind of prompts, so please use some. There is an 80.15% chance that given a person walks into the nurse's office with a fever, that person has the flu. All right. Well, that was the whole thing. So that's basically what your practice test, your practice test basically models your actual test, which you will receive on Friday. For right now, I posted a Quizizz.com assignment that is a review of these concepts, these basic skills, and I'd like you to do it now. We are about 15 minutes in, so you've still got about a half hour in class to complete the Quizizz assignment. It's not a long one, and we can work with someone in and around you if distance is possible. Again, if you want any support or help, you can always reach out to me, and if I'm available, I will certainly either respond through email or open a link. But for today, I'm not able to be in school. If there's any problems, please let me know. Otherwise, that's all for today. So get to the Quizizz assignment and have a great day.